This is Lab 3 magnetic field of a bar magnet. The purpose of this lab is to observe the relationship between distance and magnitude of a magnetic field and determine the magnetic moment of a bar magnet. The physics concepts you need to know are the Biot-Savart law and distance dependence equation. In the end, I found the magnetic moment was 1.545 amp meters squared. This is a little outline of what the lab looks like with our bar magnet and finding the distance, and then using the numbers on our phone from the Magnetometer app to put into our sheet. The procedure. First, you have to use the Magnetometer app to determine where the Magnetometer chip is in your phone. And then you have to find the distance for each X component magnetic field and then put that into the spreadsheet. That is the experimental part. The coding part, you also need to find the distance in an X direction and then go up in the Y the same amount, and then you enter in your XYZ components of your magnetic field into the spreadsheet to get your total magnetic field at that given position. Some observations during the lab was that when the magnetometer was far away from the magnet, it measured near zero in the X direction, and as the magnetometer moves closer to the magnet, the measured X component of the magnetic field increases. Our calculations. First, we want to find mu, and to do that, we need to know k. So I found k. Using the y-intercept, we know that that's natural log k. And then plugging in a few more numbers, we got the dipole moment was 1.545 amp meters squared. So our coding part, put in that number we just got, wrote a code to find our dipole moment using the Biot-Savart law, and then gave a distance and put it in every direction, positive and negative, which are these orange and blue arrows. And then we also found the perpendicular one by plugging in the numbers from this spreadsheet and ended up getting a magnitude of 1.37893 times 10 to the negative fifth for that one. So we compared that to the experimental results, found it was not too great, about a 250% difference, and the possible errors that caused that were inconsistent measurements, the phone not being aligned properly, and the magnet isn't perfect. It might not be all aligned inside of itself. And then our questions. What if we hadn't oriented the experiment to compensate for the magnetic north? It would just mess up our calculations, basically. We only want the magnetic field from the bar magnet, so if the Earth's magnetic field was a part of that measurement, then the results would have been the sum of the Earth magnetic field and the bar magnet, which is not what we wanted at all. And if we were to stick two identical magnets together end to end, it would increase the magnitude, but the direction would stay the same for all of our calculations.